Good morning, kiddos. This is Mrs. Williams. We're going to start our first lesson on quadratics and factoring. I'm going to do 3 lessons, just taking it slowly step by step so you fully master this concept. All right. So first to review this, we're just going to review the multiplication of binomials. And we know how to do this either distributing or using the box method. So I'll just go through this quickly. But I am going to point out some things at the end of each multiplication process that we do. So just using the box method quickly here, you know I have to combine the like terms. So I get x squared plus 6x minus 27. So now what I'm going to ask you to do is look at all 3 of these terms that I just got. Look at the x squared, look at the plus 6x, and then look at the minus 27 or negative 27. How do those numbers relate back to what we started with? Just think about it for a minute. How can you tell it's going to be an x squared? How do you know it's a positive 6x? Sure, you can do the multiplication. How do you know it's going to be negative 27? So just think about that. That's going to come into play when you start to factor. All right, so now let's look at the next one. I'm going to change colors for you. All right, so this one is again just a binomial times a binomial. So I'll just quickly go through this. So I get my 2x squared, my 3x, my 4x, and my 6. Combining like terms, I get 2x squared plus 7x plus 6. Again, how do these numbers relate back to up here? Okay. The next one I just threw in there just because so many students make silly little mistakes on this one. So remember, the quantity 2x minus 2, quantity squared, means this. That you're actually taking the entire quantity by itself again. That's what it means. It doesn't just mean 2x squared minus 2 squared. That's not what it means at all. Okay, so I'll do the quick box method here. So 2x and negative 2 and 2x and negative 2. So I get 4x squared minus 4x and positive 4. Combining my like terms, 4x squared minus 8x plus 4. Okay, so again, looking at this one's probably the expanded form here. This one's probably easier to look at. How do these numbers relate to what you had up there? Okay, last example we're going to look at before we start defining some terms and do some matching and then identification. We're going to do one more multiplication of binomials. Alright, so x and negative 1 and x and negative 8. So I get x squared, I get negative x, negative 8x, and positive 8. Combining my like terms, this is what I get. So I want you to think about that. How does the 1x squared relate to what we started with up here? How does the negative 9 relate to something in that factored form? And how does the positive 8 relate to it? So I'm going to be using some terms, factored and expanded. Okay, this is called factored form. Okay, when it's in the parentheses, when it's a binomial times a binomial, that is called factored. In fact, this is a factor and this is a factor. Okay, this form, we multiplied it out, right? We expanded it. So it's expanded form. So this is expanded. And when you write it in decreasing order with degrees, just like I have here, it's also called standard form. Okay, once you get that down, I'm going to color in some of these little guys here, just because it's kind of fun. Okay, moving on, let's go to the next page. So let's define some terms, and I want to get a skinnier pen here. Okay, a quadratic function is in this form right here, and let's talk about this. We know f of x is the same thing as the output or the dependent variable. You could also have a y equals here. It would be the same thing. It's going to be equal to a x squared. So the coefficient of the squared term is called a. We will use that a lot. The coefficient of the x or the linear term is b. And I bet you can tell what the coefficient or just the constant term is. It's just c. So this is a quadratic. This is standard form of quadratic. Okay, ax squared plus bx plus c. The square is the highest degree. So all quadratics have a degree of 2. All right. So one other thing that's important here. The a, the b, and the c are numbers. Okay, so just regular numbers with a not equal to 0. Okay, it's not going to be a quadratic if the a is equal to 0 because then it's not a square term. Okay, quadratics have a square term in them. All right, some other things you'll hear me saying that I want you to be aware of. A is also identified as the square term, and that's simply because it is a x squared. The b term is also identified as the linear term because it's just a simple old x next to it. The b is the coefficient of the x. And then the c is just the constant term. It's just a number. Okay, so now we're going to identify some terms here. So before we do that, let's go ahead and write on top that a is the square term. Let's write that b is the linear term, and some of my letters disappear, but it's okay. You know what I had up there. And c is the constant. I'm going to fix the red one just because it bothers me. We'll see if it stays. Okay. So again, these terms are only the coefficients. They are not, never include the x or the x squared with them. They are only the coefficients or the number that's being multiplied by the variable. Okay, so the a term in this one, always include the symbol, is -3. Okay, the b term, including the symbol, is that coefficient of the linear. So this is a +6. You can put the plus, you don't have to. And then I am just for getting used to it today. And then the constant, always include the symbol, so it's a +9. I'll just put +9. Okay, very easy just to identify those. Okay, so let's look at the next one. I'll give you a moment to write down what you believe are the a, the b, the c. So go ahead and do that for me. All right, so the a term, +1, because it's understood that there's a +1 there. It's an invisible 1. The b term, including that symbol, is -3. And then the c term, including the symbol, is -4. Okay, 2 more to go. You can see I used f of x on these two, but now I'm switching to y, and that's okay. It's the same thing. It's the output or the dependent variable. Give you a second to write down what you believe the a, the b, and the c are in this next quadratic. Okay. The a is a -1. The b is a +1. Again, you can put the plus sign or not, it doesn't matter. Actually, preferably no. I'm just doing that so you can see it easier. And then the last one, the C term, is the 2, the positive 2. All right, now the next one's trickier. Doesn't change anything just because I have the y on the right side. We know that we could simply we change that around if we wanted to. You know, that's the same thing as this, right? Isn't it? Sure is. Okay. All right, so now let's just assume that it looks like this. Y equals 4x squared minus 9. Okay, think about that. Think about what your A, your B, and your C are. Okay, your A is pretty straightforward. Your A is still going to be the positive 4. What's your B? Let's go back up and look at what the B term is. The B is the coefficient of the x. B is identified as the linear term. It's the coefficient of the x. Okay, do I have a linear term in this equation or this function? Do I have a linear term? I don't. I don't have a linear term. Okay, and that's okay. As long as I have a square term, it still is a quadratic. So my linear term in this case is simply 0. So you put 0 there. All right, and then lastly, your C term is just the constant, which we know is negative 9. Okay, there's not an x term, so that's why this is 0. Okay, next page. I think this is the last page. All right, so what I want to do here is just first remind ourselves what these two different things are called. And I did it up in the title of it, but let's do it here. So these are factored form, and these are expanded, also called, and they're all written in standard form in decreasing degree order. Standard. Okay, so what I want us to do is to match the letters over here to the matching number to the right. And try to come up with ways. You don't have to necessarily do the box method every time. How could you do that? This one, let me point out here, is negative 4. Okay. What do you think about it? How do you know which one goes with which one? You can write them all out, expand them all by using the box method, combining like terms. See if you can come up with a quicker way to do that. Think about that. Okay, in years past, I'll tell you what some students have noticed. And since I don't have you here with me, I'll tell you what they noticed. They said that 5 and A go together. And they said that because the C term is negative 12, and they knew that it was going to be negative 3 times positive 4 that gave them that answer. So they knew that A went with 5, and it was the only negative 12 C term over here. Okay, so let's do the same thing with E. Looking at the remaining numbers on the right, in the right column, we know that it's going to be negative 3 times positive 6. That's negative 18. This is the only one. So E and 3 go together. You could do the same thing with D, with positive 9 and the positive 1. That equals 9. This is the only one with 9 as the C. What's special with this one is a couple different things. The plus 4 and the negative 4 is going to give you negative 4, but also this one is the only one that has a coefficient with the x. So 2 times x has got to be 2x squared. So C and 4 go together. And then we have one left over, but let's make sure that it makes sense. Remember, this is the same thing as x minus 2 and x minus 2. If I were to multiply negative 2 times negative 2, it'd be negative 4. That makes sense. Okay, so we did some matching. We thought about how they would relate to each other and what strategies we could use to sort of eliminate and narrow down our options. So now, what I want you to do is kind of using that as a model a little bit, and then even going back to that first page. Let me use my little stylus here. And looking at maybe some patterns that we used there. You know, this one matches the same thing that we did before. The negative 1 times the negative 8 equals positive 8. What about this negative 9 in the middle? How do I know it's negative 9? How does that relate to what I started with? Okay, so let's go back here and think a minute. Okay. So I'm going to go ahead and do the box method. Okay, I'm going to do x and positive 1 and x and negative 7. I'm going to get x squared and x and negative 7x and negative 7. I'm going to combine them. Part. Negative 6x minus 7. Well, this makes sense. How do I get the negative 6? How do I know that? Just by looking at this. Think about it. Okay. Well, I'll tell you that the next one is this. X squared plus 11x plus 18. How do I know that? And I'll tell you the last one. X squared minus 8x plus 15. I didn't use the box method. I just looked at it. What patterns do you see with the B and the C terms? I'll highlight the B and the C terms. Okay, so here's the B term, here's the B term, and here's the B term. And then the C is here, here, and here. All right, let's start with the C, easier of the two. The C term is simply, I can get a good place to write this, is the product of these two terms. What's product mean? Right, multiplication. Product of 1 and negative 7. Does that work for this one? The C is the product of 9 and 2? Absolutely. Aye. Poopy dust. Okay. And then the last one, the positive 15. Is that the product of negative 5 and negative 3? Sure is. All right, so that's how we get our C term. All right, but the B one's a little bit more difficult for most people to see. Haha, C, B. All right, let's look at the C term. Maybe the second one is the easiest one to look at. Let's look at this one. It's the C term of this one. The B term. The B term of this one is 11. How does 11 relate to anything that's in this? Positive 9 and positive 2 added, do they equal positive 11? They do. They do. What about the B term here? Negative, gee whiz, it's annoying. What about the B term here? Negative 6. Positive 1 and negative 7. You combine those. Does that equal negative 6? Sure does. Well, let's look at the last one. Negative 8. -5 and -3, combine those. Does that equal -8? It sure does. So let's, oh dear, let's try something here. I'm going to give you another problem here. So let's do x. Let's do x squared. Let's see. Oh no, let's do this. Sorry, I did it the other way. So let's do x minus 6 and x plus 2. That's the factored form. What do you think the expanded form is going to be? Well, you know it's going to be x squared, and you know it's going to be -12 at the end, because -6 times +2 is -12. How do you know what the b term is? We just said it's got to be the x, but it's the combination of -6 and +2, -4. If you were to multiply this out and use the box method, that's what you would get. Okay, let's do a different one. Let's do x plus 9 and x plus 8. Okay, we know it's going to be x squared is the a, or the a term. The a is 1, then the x squared. Then we know the c term is +72. We know there's going to be an x. What is the b term? Well, the b term is simply these guys added together. Simple. So you can go very quickly now, especially when the a is 1, from factored to expanded or standard form. Okay, so we're going to practice that a little bit now. You can always check your answers by I'm doing the box method just to double check.